Section 4.4, Writing and Solving Inequalities. We're going to write inequalities and represent inequality solutions on number lines, meaning we're going to graph them. Okay, so writing an inequality. So when we write an inequality, we take a sentence and we turn it into an inequality math statement. Okay, and if you recall from years past, our inequality symbols look like this, right? This is less than, this is greater than, this is less than or equal to, and this is greater than or equal to. Less than or equal to is less than or equal to. So that's why you combine these two symbols, and that's why there's an extra line underneath. Just like greater than or equal to, you add that, combine these two symbols to make this one here. Okay, so up here I have a table, and in the table there are common expressions that can be translated to the different inequality symbols. So is less than, is fewer than, that's this sign here. Is greater than, is more than, is equal to that sign there. Is less than or equal to, is at most, is no more than, that would be the symbol here. And then is greater than or equal to, is at least, is no less than, and that's this symbol here. Okay, so I left this up here so that when you translate your sentences, you can look for these key words and then you'll know which symbol to use. So, for example, we have this sentence, a number q plus 5 is less than or equal to negative 7.9. Okay, so let's look at this first part. A number q plus 5. Well, a number q plus 5 is less than or equal to, negative 7.9. And that is our inequality expressed in math symbols that is equivalent to this sentence here. Okay? So really writing an inequality and translating the sentence is really just looking at the clues within the sentence and matching it up with the symbol, and yeah, pretty straightforward. Okay, so given that, why don't you fill out the first section of your notes? Again, all you're going to have to do is translate a sentence into an inequality, and all I'm having you do is write the appropriate inequality symbol. So look at those key words, and in your notes, I did put that table there too for you to reference. Okay, and now that you've had a chance to write in your notes, we're going to talk about checking inequality solutions. So that's going to be when we determine if a value that we're given, if it's in the solution set, meaning does the value that we're given, does that make the statement true? Okay, so in this table here, we're going to do a bunch of examples. So we're given different values of x, we're given an inequality, and we're going to determine if this value of x makes this inequality true. So first thing you're going to do is you take this 2, and everywhere we see an x, we're going to put that 2. So 2 plus 2. Is that less than or equal to negative 1? Well, what's 2 plus 2? That's 4. Is 4 less than or equal to negative 1? No, it's not, is it? So the inequality is not true when the value of x is 2. Let's try when the value of x is negative 2. So negative 2 plus 2, is that less than or equal to negative 1? Well, what's negative 2 plus 2? That's 0. Is 0 less than or equal to negative 1? No, it's greater than, isn't it? So again, negative 2 does not make that statement true. Okay, let's see if we try x equals -3. So -3 plus 2, is that less than or equal to -1? Well, -3 plus 2 is -1. Is -1 less than or equal to -1? It is, it's equal to. So yes, the value of -3 makes this inequality statement up here true. Okay, let's try -4. So -4 plus 2, is that less than or equal to -1? Well, -4 plus 2 is -2. Is -2 less than or equal to -1? Yes, it is. So again, excuse me, the value of -4 makes the inequality true. Okay, so when you're given a value of x, you can plug it into your inequality and see if the statement is true. Okay, so that's how you check an inequality solution. So let's look at this one here. Let's tell whether -2 is a solution of y minus 5 is greater than or equal to -6. So we're given a value of y. They say -2, so let's plug that in. -2 minus 5. Is that greater than or equal to -6? Well, what's -2 minus 5? That's -7. Is -7 greater than or equal to -6? Remember, think about your number line. Here's 0, here's -6, and here's -7. Is -7 greater than -6? No. So -2, so x equals -2 is not a solution. Not a solution because -7 is actually less than -6. Okay, again, time to write in your notes. You write in the middle section of your note sheet, and you'll just be completing a table and determining if -5 is a solution to each of those inequality statements in the table. Okay, now that you've had time to do that, we are going to move on to graphing inequalities. And this is just a review from last year, so we'll make it fairly quick. Again, up here I have the different symbols: less than, greater than, less than or equal to, greater than or equal to. When you graph inequalities on the number line, the graph will be an arrow and a circle. Okay, so an open circle means that the number is not included. So if we had, let's see, x is less than 2. Okay, so if we want to graph this one, so we know less than 2. So let's find 2 on our number line. We have a circle here, and it's an open circle here because our solution is not going to include 2, right? If we wanted to include 2, it'd be x is less than or equal to 2. But we're not doing that one right now. We're doing x is less than 2. So it can't include 2, but it can be all the numbers less than 2, right? Okay, so that's what the graph of x less than 2 looks like. But what if we wanted to do, let's see, x is greater than -3? You find -3 on your number line, write a circle. X is greater than -3. It doesn't include -3, so we leave it as an open circle, and it can include all the numbers greater than -3, right? So our graph would look like that. Okay, now what about x is less than or equal to 4? Okay, so we find 4 on our number line. It's less than or equal to, so it can include 4. So let's color in our circle. And it's all the numbers less than or equal to 4. So the graph looks like that. Okay, last one. Let's do x is greater than or equal to -3. Okay, so we find -3 on our number line. It's less, excuse me, x is greater than or equal to, so it includes -3, so we want to color it in. And it can be all the numbers greater than -3. All right, so these two symbols, when you graph them, your circle will be colored in because it can include that value, right? But for these two symbols, when you graph them, it's an open circle because the solution does not include that number. Okay. Again, that's just a review from last year, just a little refresher. But I do have some notes for you to write in just so you can remember if a closed circle or an open circle goes with which symbol. Okay, now it is time for you to do some practice problems. There are 1, 2, 3 of them. Okay, now that you've had time to do those practice problems, let me kind of give you some hints about them. Okay, for the first one, write the inequality for a number y minus 3 is greater than negative 15.3. So a number y minus 3 is greater than negative 15.3. So what symbol goes in there? Is greater than. Okay, now number 2. Tell whether -2 is a solution of negative 5.5y less than 14. Okay, so let's plug in our -2. So negative 5.5, -2. Is that less than 14? If it is less than 14, then it is a solution. If it is not less than 14, then it is not a solution. So you can now do that calculation and figure out if -2 is a solution or not. And the last one, number 3, we are going to graph the inequality. T is less than or equal to 2. So first step, find 2 on the number line. Okay. Now you have to ask yourself, do I color in the circle or not? Okay. So is it filled in or is it open? Okay. So you have to ask yourself that. And then which direction will your arrow go? Does it go right or does it go left? Remember, T is less than 2. Okay. Good job. That ends 4.4.